To make a shadow shader, start off by getting yourself a 2D texture that is both seamless and is also a uniform square. I get my images from pixabay.com, but you can get yours from wherever you get 2D textures from, as long as they are, again, both seamless and a uniform square. Once you have your texture, you can start off by opening up Shader Graph by creating your own blank custom shader. We're going to name this one Chowder Shader. In case you are not familiar with the 2020 version of Shader Graph, here's a link to a YouTube channel called Zero, who goes over the newest updates to the 2020 version of Shader Graph. So the first thing we're going to do in this shader is, of course, set the target of the shader to universal, and then make sure it is an unlit shader. You can do this as well with a lit shader, but for our case, we only need the base color. Next, we're going to want to go over the Shader Graph Node Properties Manager and add a new property that is a 2D texture, and we're going to call this Chowder Texture. You can set the defaults of this texture in the node settings. So in our case, we're going to set the default to our previously acquired background. Next, you're going to drag the node into the shader graph itself, and then link it up to a sample texture 2D lot. With this, you now have your background texture in the actual shader graph, allowing it to be manipulatable by the environment. If we hook it up to the base color as is, we of course have our shader attached to this object, which allows us to see it in the main preview. Now this of course is simply a static material at this point. It does not move with the camera as a typical Chowder Shader effect does in the show. So to do this, we're going to press space and add another node called Position. Position gives us a certain vector 3 position output based off of the presets, of which we have object, view, world, tangent, and absolute. If we attach the output vector 3 of the position node to the UV section of the sample texture 2D graph, you'll find that suddenly the main preview shows this very weird image. This is because our background texture is currently in the sprite 2D and UI texture type. To solve this, simply make it go to default and hit apply. Now that we do this, we can see that the image on our main preview is now fixed to this certain perspective. To get a better idea of what this looks like, go to cube, and you can see that the image, even though the cube is changing, maintains its rough shape on the texture. To see what this looks like in the actual world, we're going to go to Scene View and create a cube. This cube will act as our test object for creating our chowder material. So now we're going to go to Create, and instead of making another shader, we're going to go to Material, and simply title this Chowder Material. Selecting the shader drop down here, we're going to go to Shader Graphs, where we can see our chowder shader right there. Clicking that gives us a chowder shader in the scene itself. So simply drag and drop. Now with our chowder shader applied to the object, we can see how it acts in the world state. And as such, it's a bit wonky and not exactly what we want. But if we do move it around as such, we can see that the effect is roughly there. To fix this, all we need to do is set our space in our position node from world to view. This will change it so that the view of the node is actually what determines how the node looks. So instead of having to move the node, which will still change the effect, if we just move the camera around itself, the node will also change shape. And with this, you have your Chowder Shader. This can be applied to any 3D object and or material, and even can be applied to whole sprites. If this shader does seem, however, too stagnant for you, you can also add a moving effect to the shader to increase the overall appeal. To do this, start off by adding a time node to your scene to add an incrementing value to your shader graph. Then we're going to add a vector 3 that we can then manipulate and add to our position using an add node. With this, add our position output to the a value of the add function, thus recreating the same value, and then add the vector 3 output of our current vector 3 node to the same b value of the previous add node, and then hook that up to the output of the UV instead of the original position node. With this, nothing should straight up change. However, if you notice now, whenever we change the x value or the y value of the given node, it changes the current position of the UV texture on the current object. Following that, we can then add the time node to either the x or the y of the vector 3, either of which is adequate enough, but depending on your preference, you could add it either way. And this then animates the actual material itself. If you wish to see it in the actual world state, this is what it looks like as is. If you may, like me, find that this texture is actually moving a bit too fast for your liking, you can simply add a divide node and divide your time value by whatever x value you want, and then output it into the vector3 node. This will then slow the graph by however much you divide by, and if you want to change this value in your actual game state, you can set up a new node in your properties list to then change that. And with that, we have added a small animation to the overall shader graph to allow the Chowder node to look like it's constantly moving. Now, in case you want to have a more in-depth texture when it comes to your shader, rather than just have it be one unanimous block that moves, all we need to do is add a few things to our current Chowder shader to enable that effect. To do this, I've grabbed a quick stickman figure that I will use as an example. So to start off with, let's add our stick figure texture to our current properties nodes. Simply create another texture 2D. We're going to call this one default texture, and then set in the node settings the default of it to be the stickman. Now drag this default texture into the shader graph and set it up with a sample texture 2D LOD. With this, we have both our original texture that we want to cover over and our shader graph texture itself here. What we're going to add next is a replace color node. The replace color node does exactly what it sounds like it does. It simply replaces one color with another, or in this case, one vector3 with another vector3. So we're going to start off by putting the RGBA of our sample texture 2D LOD of our default texture into the int values, thus creating the image here. And then we're going to link up the RGBA of our Chowder shader to the to value of the replace color. Doing this will make the replace color node displayed in spherical form. To see it on the screen better though, we can simply output this to our fragment base color. Now you may notice that this still doesn't look like it's affecting both the Chowder shader and our default shader, and that's due to the fact that the range is currently set to 0. The range is simply how much the node is being told to consider one pixel to be one color or not that color. In this case, it's currently going through all of these pixels on the default node and deciding how close it is to our current value, which is black, and deciding that if it's not exactly the same color black, it won't change the texture. If we increase this, we'll quickly find that the texture will in fact decide that more of these pixels are in fact the same black color and replace the node. So you can see now that all of these current textures have been replaced with the Chowder shader texture. If we invert this, simply by going to the sort of black color here and selecting white instead, you can now see the black outline of the stick figure surrounded by the actual outline of the moving Chowder shader in the background. If we go into our scene now, we can now see this in the actual game world, with each of the sides of the cube displaying the current figure. And with that, we have made our Chowder shader. If you have any questions, please leave them in the comments down below. I am planning on making more of these quick and dirty shader graph tutorials in the future, and the easiest way to keep track of them is to follow and click on the bell icon. With that being said, I hope you guys enjoyed, and see you next time.